What-o! Yes, I've returned. It's been a week. I'm just doing a bit of research into solar thermal energy, or solar energy that's derived from sunlight. I'll say that again. When comparing solar panels to solar thermal, I have found a bit of a problem. There's no real point in solar thermal. Rather, there is a point in a solar panel. Let me explain. For a solar panel, it collects around 125 watts per square meter per hour. The average house, at least for an American, is 3000 watts or 3 kilowatts per hour, charged up over 10-hour periods to make a full 30 hours per day. 10 hours, as it's much shorter. Make the panels more powerful. The max capacity for a solar panel, if it were max solar efficiency, would be around 625 watts. 5 times greater than the 125 watts of a 20% efficiency solar panel. Therefore, an American house would need approximately 24 meters of which squared. The average temperature for a hot country is around 30 degrees Celsius. Celsius because fuck Fahrenheit. However, you can't go wrong with an online calculator. I found Celsius heat units IT per second watts CHU divided by seconds or per seconds for watts. The goal is 30,000. The goal is 3,000 per hour. If the temperature of air is 30 degrees Celsius, it would therefore equal, if the camera will load, around 56,973.01608 watts. However, that is a degree Celsius per second. I don't know if it should be calculated as a degree per second, per minute, or per hour. Considering you feel the breeze of a heat on a hot day, if you just come out of a cold environment, it would be a second. However, it would take probably an hour for that much. Let's find. There's lots of mathematical jargon in the rest of the website for this calculator, including things like CHU divided by seconds or per seconds. That's never been explained. Then I found this website about solar thermal. To be precise, it's by Clean Energy Council, subject solar thermal. It states, if I can find it here. There is a 9.3 megawatts, or millions of watts per hour, or just millions of watts, per 18,490 meters, of which squared. If I just go to my calculator again. Therefore I need, so 18,490. I think I am a bit more nasally today, even though my nasal capacity or my nasal cavity is perfectly normal. I am talking from behind the camera of the phone, so my voice may be even different compared to that. Around 18,490 meters of which squared, multiplied by a minimal of 125 watts per square meter per hour, equals 2.3 megawatts, a max capacity of 11.5 megawatts. For that amount of cover, this company in Australia, with concentrated solar thermal, has 9.3. So, I should have really scripted this video. 3 9.3, oops, divided by 2.3, that's 4 times greater than if it was covered in solar panels. However, the max would be 5 times more powerful, as a full 625 watts per square meter per hour is 5 times 125 watts per square meter per hour. I think if I talk deeper, my nasal cavity grows up. It's one of the worst parts of the human body. In your mind, you could have the mind of God, or rather, in your mind, you could have the voice of God, or as you speak, you can try and have the voice of God, or Morgan Freeman, but the moment it comes out of your mouth, it's affected by the nasal cavity. My nasal cavity isn't even that stuffed. I've cleansed all of its snot and compounds. Therefore, solar or concentrated solar thermal in Australia would be around 4 times greater than if it were comprised of solar panels. You just need a lot of fluids such as water or liquid fluoride, probably, like in a liquid fluoride thorium reactor. However, I've found, I'll do this again. What's the Celsius? That'll do. That's per second, per minute. I'll say for a medium ball, as it would be. I should have scripted this entire video. If it is all per meter, then I would need 125 watts per meter. That equals the temperature in the air would need to be 3.9 degrees Celsius. However, that is freezing. To put Celsius into comparison, 5, which is a bit more than 3.9, is about as cold as snow, or over 0 degrees is as cold as snow or ice. 5 is a cold day. 15 is either a warm day of autumn or a cold day of spring, medium day of spring. Then there's the full summer or sunny country with a temperature of 30 degrees Celsius. I'll try and flip this around. There should be, there we are. Celsius heat units, IT per minute per watts. Give it a second. Celsius. Celsius per minute. Look what's happening. That was 3 cubic centimetre. Is that what it's using? I've assumed it was per metre. I've been calculating this for a fair few minutes. I found it's either far too little or far too much. So, my question for today is the capacity for solar thermal greater than the capacity for a solar panel? Please let me know in the comment section down below. I'll see if I can reply as soon as possible. I might have to trust this website as it doesn't give me such bullcrap about Celsius per second, minute or hour, or how much energy in watts that is equivalent per hour. Perhaps it's also a matter of acceleration and deceleration of heat, like a Stirling engine. A Stirling engine is propelled by the difference in temperature. You know, perhaps it's a matter of like a Stirling engine. I think I'll prefer Clean Energy Council. For one, the website has pictures.